What's up guys, Nafal here from Nemco. Today I'm going to show you how to build your mine-wide model for stress modeling in less than 10 minutes using IMAT. That's right, not 10 days, not 10 hours, 10 minutes. First off, what's IMAT? IMAT stands for Itasca Mining Analysis Toolbox, which is a game-changing solution designed to revolutionize geotech modeling and seismic analysis. It's a very powerful tool that allows to easily import geometries, set up boundary conditions, set up materials and mining sequence. And the best of all, interactively visualize your stress results along with other available field collected data. All right, let's jump into it and let's get the ball rolling. We start with creating a new IMAT project where we input the project name. We can select the location of the project and its name in our folders. For the mine name, I could just say example mine. The rest is good. So the first thing we do is to import our geometries. I like to start with development. I've already saved all my raw geometries in the development folder that comes by default in IMAT, so I can go and get them. I don't have to convert any coordinates. And I do the same thing for the other 2060 level developments. I can select them all and show all of them in the viewer window. Then all good. Then I can go and do the same thing for stopes. So typically for stopes, it takes a bit more time just because the files are more sizable. And I can also show the geometries in the viewer once I'm done, once the program is done importing them. And what's great with IMAT is that I can simplify them significantly. So by simplifying them, the software creates new simplified files. And the good thing is that I don't have to do one by one. It does a batch thing. Now the trick is that DXF don't get simplified until we extract the geometry from them. So they are converted to STL. Then simplification could be carried out. So now I only show the simplified geometry, making sure that they're okay. You can see that they're still too detailed. And IMAT has this amazing geometry feature called shrink wrap. Basically it will create a surface with cells that will wrap on the geometry and thus created a much simpler geometry. So usually 5-meter cells has worked well for me in most cases. So I'm gonna go ahead and shrink wrap them. And it's just a matter of few seconds and all these stopes that are really sizable become very simple, and it's very handy for modeling. You can see how fast that was, and that's exactly the very reason why I like this program, because it has been built for geotechs in operation that don't have time to play around and do double work like it's the case in other programs. So if we look at the results, it's amazing. So let's delete all the other geometries, and don't forget that all the raw files are still in our folders. So for development, I also have to extract the geometry because those are DXF. And let's have a general view. Perfect. Let's randomize colors. Good. For geometry, we're done. So now let's go ahead and create a new Flag 3D project. I will have tunnels, backfill, and stopes. And let me change a bit the solver settings and relax my conversions criteria just to get quicker runtime. Although I recommend keeping the default settings. And let's define our in situ stresses. For my elevation, it would be 500 meters, and I have to set up my variation of stress component with depth. Um, Here we go. And I don't need to add gravity to the calculation. I'll just uncheck that. And we can visualize the far field stress tensor once I'm done my sigma 1. Here we go. Then let's jump into the mining steps. We will have 7 steps, and the step duration will be monthly. Then once I'm done, then what we do is just simply copy the relevant geometry to be extracted into the corresponding mining steps. So we have to do it for every mining steps. Now there is another way to input the mining steps automatically that will be covered in another video. Here we go, last step. And then once we're done, then I will hide all the geometries and I will review my mining sequence. So I'm just gonna go and for every mining step show these geometries, and it makes sense. It's a retreat sequence. We shouldn't forget the backfill properties and enable them in different mining steps. Here we go. And now it's time to place the model box, which is the external boundary. So for the sake of simplicity, I will choose the smallest possible model box that will encompass my geometry. So I'm just gonna play around a little bit with the values until I have a satisfying model box. Here we go. Good enough. So for the boundary conditions, IMAT set them automatically by default. So now let's jump into the refinement of the octree mesh around the geometries of interest. So we can go about it by different levels as we approach the regions of interest. IMAT's allowed to select which geometry type will be subject to the mesh refinement. And the way it works is that the octree mesh refinement is always based on the cell size of the model box. So if we start off with 10 meters, then level 1 would be 5 meter, level 2 will be 2.5 meters, level 3 will be 1.25 meters, and so on. Now I'm setting up level 3. So I'm just gonna go and say specifically that I want selected geometries, and I'm gonna say the geometry from the distance from geometry 2.5, and then I'm gonna go and select a couple of levels. Here we go. So this is where I want to see the more refined octree mesh. Now we jump into the materials, and for simplicity I will only run an elastic model, and I will change the default values. And once I'm done, I will go ahead and build my grid. Here we go, and then I wait a few seconds and I gotta check my grid size. Seems okay. And I go ahead and run the Flag 3D solver in IMAT console. You can see that I don't even have to open Flag 3D for this. After about 20 minutes or so, my model was already done, and I was able to visualize parameters like sigma 1 contours in cross sections or plan view as I changed my mining sequence. I can even create animation for the stress change with mining sequence and much more using this powerful tool.
That's it for today. Another solid blocks in your modeling foundation. Stay safe and see you next time.